Don Machholz, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 113 for the week of March 2nd, 2022. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, March 2nd, the moon will be new. New phase is on Wednesday, March 2nd at 1734 Universal Time. That night and the following night, try to find the thin lunar crescent in your evening sky. By next Tuesday, March 8th, the moon will be 30% full in our evening sky, a crescent moon. In our morning sky, the planets Saturn and Mercury will be within a degree of each other on Wednesday, March 2nd. They will be 23 degrees from the sun in the pre-dawn southeastern sky. Mercury will be slightly brighter than Saturn by about a degree. On March 7th, the moon passes in front of the planet Uranus as seen from the Earth south of the equator. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, March 2nd through Tuesday, March 8th? It depends upon where you are located. This week we have 7 zones. Now all you need to know is your latitude. 3 areas will not see the International Space Station at all this week. They are north of 63 degrees north and south of 50 degrees south. So as you head towards the poles, you will not see it. Also, the equatorial area between 30 degrees north and 5 degrees south, it will not be visible from those regions. But between 36 and 63 degrees north, you will see the International Space Station in your morning sky, sometimes twice per morning. And between 30 and 36 degrees north, you'll see it in your morning sky, but only for the last part of the week. With the Northern Hemisphere seeing it in their morning sky, the Southern Hemisphere will have it in their evening sky. That's how it usually goes. Each hemisphere has it in a different sky. Between minus 25 and minus 2 degrees, the ISS will be in your evening sky, but only for the last part of the week. And between 50 and 25 degrees south, the ISS will be in your evening sky for the whole week, sometimes twice per night. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. Several comets are still visible in our evening and morning skies. They are plotted on podcast 113, map 1 and 2, which you can get from my website. Now, to get the most accurate and up-to-date positions for these comets, go to the website heavens-above.com and click on comets. There you will find the positions and maps for each comet. Last week, I ran into a problem with my digital setting circles on my 18-inch reflector telescope. I use this instrument to visually comet hunt, and I have been using it since I bought it secondhand in 2006. When I bought this Dobsonian telescope, it had no setting circles, and I found myself picking up many more nebulous objects than I did with my 10-inch reflector. And with each such object, if I did not have the surrounding area memorized, I had to pull out the star atlas, figure out where I was in the sky, Then see if the nebulous object was in the star atlas. If it was, then it was a known galaxy, nebula, or cluster, and it was not a comet. All of this takes time out of my comet hunting session. So I bought electronic setting circles. This kit consists of a small computer box mounted on the side of my telescope tube, and it is fed by a power cord to the batteries that are in the telescope tube, and two wires. Each one is attached to an encoder. The encoder is a small electronic rotary device attached to each of the two axes in the telescope. It measures the amount of rotation of each axis. After I align the telescope on two stars, the display in the small computer box tells me where I am pointed and if there is supposed to be a nebulous object in that part of the sky. Well, last week one of the encoders stopped working. I checked to see if it was a cable, but it seems to be the encoder. This is the one on the base of the telescope. It registers as you move the telescope from side to side. After 15 years and more than 1,800 hours of comet hunting, perhaps I've worn it out. It looks like I can get a replacement costing about $100, and that may have to wait a few weeks. So what do I do in the meantime? I don't want to stop comet hunting. I could use this telescope and manually research every fuzzy object that I find. Now that is one solution. Another solution is to use another telescope, and that's what I'm doing. My 10-inch reflector does well, as does my homemade 6-inch binoculars. And a couple years ago, a friend of mine gave me a 16-inch reflector that he did not want anymore, so I have used that too. The weather here in Arizona has been good these past few months, so I have been able to get a lot of sky time. Let's change the subject. Light pollution caused by artificial light makes it difficult to see faint objects in the sky at night. It continues to get worse each year. It affects the visual astronomer more than those imaging. The question is, what can be done to still see faint objects despite light pollution? I want to tell you the story of what I once did. In the mid-1980s, while living in San Jose, California, then with a population of 600,000 people, I decided to try to do some comet hunting from my backyard. I typically commuted to my usual comet hunting site 40 minutes away in the Santa Cruz Mountains, a location known as Loma Prieta. I did that for 15 years. But when the road up there had snow and ice, or there was only a short observing window due to the moon, I wanted to see what I could do from San Jose. As you know, I tried a lot of different things to help improve my ability to see faint fuzzy objects, and this was just one of them. 2 images of the setup are on podcast 113, Overhead Telescope, which you can get from my website associated with this podcast. I would be using my 10-inch reflector telescope, which I normally use for comet hunting. It has a short focal ratio, f3.8, which gives a wide field of view, but it also gives a bright field. Can I change that? While I cannot change the mirror's curvature, I can change the effective focal length by using a Barlow lens, spelled B-A-R-L-O-W. It is a tube with a negative lens in it. It is placed in the telescope draw tube. Then an eyepiece is placed into that. They come in different powers, but the most common is one that magnifies 2 times. What does the eyepiece see now looking through the draw tube? The eyepiece sees a telescope mirror with double the focal length, in this case f7.6. This increased focal length darkens a field. It also gives me double the magnification and a smaller field of view. The field of view is not half of what it is, but only slightly smaller. The Barlow Lens is an underappreciated and underused tool, in my opinion. Light pollution comes in two forms. We often talk about sky glow caused by street lights and other lights nearby. Now, that is our main problem. The other, and I have discussed this too in the past, is called light trespass, such as a local street light. Now, that one street light may not light up the sky very much, but with it shining on you and your telescope, you will have trouble seeing faint objects through the eyepiece. This fact has always caused difficulties with the placement of telescopes at public star parties. An obvious move would be to place the telescopes underneath the shopping center parking lot light. That is where people can find you, and they can see that you are not a threat, and they do not need to turn on their cell phone flashlights to see what you're doing. The only problem is they cannot see anything through the eyepiece. I know. I've tried it. So instead, we move the telescopes to the shadows where it is dark and find a way to guide the visitors to the telescope. Yes, come over here where it is dark and I'll show you something through my telescope. It sounds spooky, but it works. Anyway, in my backyard, I had to get rid of light trespass, not so much from direct street lights, but from the ambient glow in the sky. So I put a small blanket, a baby blanket actually, over my head in the eyepiece area of the telescope. This gave me a dark cave from which to view through the eyepiece. They make these commercially now. They are called observing shrouds, but you can use a baby blanket for yours. If you do not have a baby, then just use a regular blanket. There is one final decision I made in setting up my backyard comet hunting program. I decided to sweep overhead. The imaginary line passing overhead through the North Star and headed south is called the Central Meridian, and that is the general area that I wanted to sweep. If I stayed high in the sky, I would be looking through less light-polluted atmosphere and would be able to see fainter objects. Now, at that time, my 10-inch telescope mount had been converted from an equatorial mount, which sweeps easily north, south, east, and west, to an alt-azimuth mount which sweeps up, down, left, and right. Thinking back now, I wonder why I did not simply pull out the old equatorial mount and use that, as it can easily sweep the overhead area. Maybe I just love doing projects and making things. Anyway, I placed the telescope in its cradle between my picnic table, oriented north-south, and my observing chair. When I tried it the first night, I realized that I had a problem. What if I picked up an object and wanted to follow it across the sky for a few minutes while I identified it? I had no way of tracking. So I built a 2x4 box frame with a screw drive that turned manually to follow objects as they moved westward. It attached to my chair, which I sat in backwards, facing the back and looking through the eyepiece. This is not a setup that would be sold commercially. It is different than a transit scope used in the earlier days for measuring star positions and telling time. No, this was used for comet hunting. So, how did it all work? Wonderfully. I could pick up 12th magnitude galaxies which was fainter than what I was seeing from Loma Prieta. I spent several mornings over the next few years sweeping the sky with this setup. The only problem is that while sweeping overhead, I could never cover the areas close to the sun where many comets were visually found. I wanted to find a comet with it. Imagine finding a dim comet under such light-polluted conditions. That would have been an inspiration to amateur astronomers who suffer similar light pollution. But it was not to be. No new comet, but some good memories. For our binocular challenge this week, let's look at the southern portion of the Milky Way. I like this area. It has a lot of contrast because there is not much dust here. So the background is darker than when we look at the summer Milky Way towards the center of our galaxy. These evenings, it's about as high as it gets in your sky. So get out there and see it before the moon gets too bright. Refer to podcast 113, map 3. Get out your binoculars and the lounge chair. Or if you are standing, rest your arms on a fence, wall, or top of your car. Face south and scan around this part of the sky. It is rich, very rich, with stars and star clusters. On podcast 113, map 3, I have outlined in red an area to sweep. If you are counting, then it is about 500 square degrees, less than 2% of the whole sky. It might take 20 minutes, but it will be worth it. If you bring out a more detailed star map, take the time to identify some of the brighter clusters you find. In a minute, I'm going to ask those with a telescope to see a particular cluster, but right now I'm going to suggest those of you with binoculars take the time to locate and observe this cluster, NGC 2477. Now, our telescope challenge is an open star cluster in the southern hemisphere, NGC 2477. It is far south, minus 38 degrees declination. So if you live in the northern hemisphere, it will be above your southern horizon. Maybe. Depends upon how far north you live. North of 50 degrees north, you are unlikely to see it. For you in the southern hemisphere, it's high in the sky. NGC 2477 is a uniform open star cluster, which overall is magnitude 5.8. It sits just north of a star of magnitude 4.5. This cluster has about 300 stars and is 3,600 light years away. It appears large, about 27 arc minutes in size, nearly half a degree. An amazing star cluster. Get out there and see it. To recap this podcast, what's up this coming week? Get those binoculars out to look at the winter Milky Way. Scan the sky and see lots of stars and star clusters. Then get out your telescope and find NGC 2477 and see some comets. You have been listening to Looking Up with Don, podcast episode number 113 for March 2nd, 2022. I'm Don Machholz. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, dontheastronomer@gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. With the moon in the evening sky, we will look at a few lunar objects. All that and more. Thank you for listening. see the sky this week. I'll see you next week.